Hi there and welcome to my channel. In this video, I'm covering the topic of transformation of graphs. It's a very interesting topic covered in lower 6 under pure mathematics in module 1. What does transformation of graphs may mean? Someone might say, well, it simply means that I'm taking one graph, an existing graph or a graph equation, and I'm going to modify it. And I'm going to apply different variations to that one graph to get my answer, to change it up a bit, right? Now, how do we go about this? Well, let's go ahead to my video. I have already divided up a few of my transformations into 4 sections, right? First section is a vertical translation, then horizontal translation, a vertical stretch, and then a horizontal stretch. In this video, I may more than likely be covering these two with a few worked examples to show you how we move from one to the next. My first category then will be vertical translation. Vertical translation, I think it's probably the easiest of all, right? It's probably the easiest to understand, the easiest to apply, right? And this is how it goes. Now, if we look at the words vertical and translation, vertical simply means moving up or down, right? And our translation is just a shift. So that is literally what we're going to do. We're going to take an original graph and shift it up or down based on the number that we are asked to shift it by, right? So say, for example, if I had f of x is equal to 2x, then if I were to graph this, get this, now what will happen is I will have a straight line here going up, but my line may not come out straight because of the method that I'm using, right? So say something like this, f of x is equal to 2x. Now, of course, when you are doing this, you use a ruler, right? So your line may look like this. Now, what if I wanted to change this original graph and I wanted to modify it, and it now becomes f of x plus 5? Wouldn't this function here be 2x plus 5? So this plus 5 now is my c over here that's mentioned, and it simply says we shift the graph up or down. So what I'm going to do with this original graph here, I'm going to modify it and shift it 5 units up. So this point here is 0, 0. Say I have another point here, say 1, 1, 2, right? That's just 2 random points on this graph. Now I want to show you what I will get for my new graph. New graph will go like this now, and it will simply be the same straight line like that. These two lines will be parallel, but it will go like this now. Now, how did I get this? I got this by taking some points here, 0, 0. That's my first graph, a point on my first graph, and I'm going to alter this, and I'm going to add 5 to this value here. So I'm going to remain with the 0 here, and I'm going to put 0 plus 5 would be 5. So this point here will be the new point 0, 5. Now this point here was 1, 2. My x value will remain the same, and this now, the 2 will now become 2 plus 5, which will be 1, 7, and that'll be one of my random points here. See here, right? Now to get a straight line, all you need is 2 points. So I could just look at these 2 points and draw up this line, and that will be the end of my first example, right? So now moving on, same vertical translation, but I'm going to do a second example. Example 2 now is if I had f of x is equal to x squared, and I wanted to change f of x plus 5, so it becomes x squared plus 5. So this is my original graph, and this is my modified graph. So the x squared graph would look like this, something like this. I'm trying here as best as possible to make it symmetrical, right? The f of x squared plus 5, well, one point here will be 0, 0, and so on. This will simply shift up by 5 units. So it will go like this. This point here will be 0, 5, and it will have the same sort of shape, the same width and everything as the original graph. These two sides here will not come in more, nor will it go out further once we're using the same scale for the blue axis and the green axis, right? So this is what will happen, right? A vertical translation. Now, let me move on to my third example on the vertical translation, and that is for y f of x is equal to e to the x. This is example 3. F of x is equal to e to the x, and again, if we're altering by plus 5, this is what our new function would look like, right? So e to the x function will do something like this, right? Like that. And this point here would be 0, 1. and this will be f of x is equal to e to the x, right? Now, if I were to change this graph here into this graph, and whether I need to get e to the x plus 5, now we have a few alterations. In this particular graph, what we should notice is that these two lines here, this curve and this line, they don't ever touch. So this is actually called an asymptote, right? Now, because it is going this way, it's called a horizontal asymptote. So, of course, there are vertical asymptotes. So, in this particular case, the graph of f of x is equal to e to the x. My horizontal asymptote is the x-axis, right? Now, for this new graph, e to the x plus 5, I will still have an asymptote. However, my asymptote will shift. So, this is what will happen. And here, 0, 1 will now shift 5 units up. So it will become, instead of 0, 1, it will become 0, 1 plus 5, 0, 6. So now that's my new point of contact with the y-axis, right? So it will go the same sort of slope and everything like that. Go like that, right? So this is now the point 0, 6. Now what happens now here, the horizontal asymptote for this one was just 1 unit away, right? This was the point 0, 1, and the line, the x-axis, is the horizontal asymptote. Now the same will happen here. The horizontal asymptote will be 1 unit away. So at this point where y is 5, I will actually have a horizontal asymptote going like this. So what we tend to do is draw an imaginary line, a dotted line, sorry, and we draw our line, our curve, and we show that our curve and this line don't ever touch, right? So this is my new horizontal asymptote, right? Where, sorry, y is equal to 5. It's so easy to mix up these letters, but try not to do that, right? So now I've covered my third example using vertical translation. Now I want to get into a horizontal translation. Now, one last thing I want to mention with a vertical translation is that in my examples, everything was a plus 5, so I moved 5 units up. If the examples had minus 5 in it, I would move 5 units down, right? So my curves will be the same shape, same slope and everything. It just would be shifted down, right? Now, moving on to horizontal translation, this is what happens here. See that we are given an f of x function and it's modified, so it becomes f of x plus a. So notice the modification goes into the function and it's not on the outside like with the vertical translation, right? So, and they tell us here if a is greater than 0, then the graph shifts a unit to the left, and if a is less than 0, the graph shifts a unit to the right. So say for example, my sum was f of x again is 2x. Now I want to change it to f of x plus 5. Now that will become 2 into x plus 5, which will become 2x plus 10. So we could see at a glance that these two curves are very different, right? This one just has this and this one has this. So this, my c is 0 here and my c is 10. So let me go to sketch these curves now. Say this is my curve f of x is equal to 2x, right? So just a rough sketch, right? Here would be the point 0, 0. Now, if I change it now to f of x plus 5, so my a is now 5. So a is 5 means that's greater than 0, so the graph will shift to the left by 5 units. So this graph now will now look something like this, right? And this point here will be the point that was originally here. It's moved now 5 units. So it will become 0, 0 will now become 0 minus 5, 0, so minus 5, 0. So that will be my new point, right? Also, say I had another point here, so this point here was 5, 10. This point will now become 5, 10, will become 5 minus 5, 10, which will become 0, 10. So that is how I would get this point here. So if you notice, there's a particular pattern with respect to the horizontal translation. We have to take away the value a from the original value of the x, coordinate, right? Curve of f of x is equal, sorry, f of x, I'll put in here, plus 5 is equal to 2x plus 10. So this is the modified curve, right? So again, if this had changed to minus 5, I will shift the curve this way by 5 units, right? And I think once you follow this pattern, it'll be easy to get the new points. Now let me move on to my second example under the topic of horizontal translation. Example goes like this: f of x is x squared, and we're changing it to f of x plus 5, so it becomes x plus 5 squared, which becomes x squared plus 10x plus 25. Now, this function here is totally different from this one. This one looks like this, something like this, right? F of x is equal to x squared. Some points would be 0, 0, another point here could be 5, 25, etc. Right? Now, to go to this one now, what I need to do is take those points 0, 0 and change them up. That point will now become 0 minus 5, 0, so it will be minus 5, 0. And another point before 5, 25 will now become 5 minus 5, 25, so it becomes 0, 25. So that means point of contact here now will now be 0, 25. And this point here, so 5 minus 0 will be around here. So remember, it's a sketch, so it's estimates, right? But of course, it must be reasonable, right? So now I could go like this. I could go like this, something like that. Oh, excuse my line. There's a flash to that point. Alright, well, it's kind of hard using this equipment for this. However, I just want to make sure that you all understand. So this is now this curve, right? So as you can see, you're seeing what is happening. So this original graph here, when it's being translated horizontally to this one. Example is f of x is equal to e to the x. Now if it's modified now to f of x plus 5, this will now become e to the x plus 5. So let's look at the original curve. F of x is equal to e to the x. We all know this is how this curve would look. This is one point on the curve. Now let us move on to the modified curve. If we look at the first curve, right, my original curve, I could see that the asymptote, as mentioned before, the horizontal asymptote is same the x-axis. Now because this is a horizontal translation, it's simply a shift to the left or to the right. So the horizontal translation will remain as the x-axis, right? So the curve will go like this or whatever, and it will still never touch the x-axis. Now if I look at the first point here, this point 0, 1, and I want to modify this, I will now take it to be 0 minus 5 because it's shifting 5 units and become minus 5, 1. So minus 5, 1 will be my new point. So say that around here. Let me go a little lower because I have to keep it for bigger numbers. So that's 1 point. Minus 5, 1. Right? Now also I want to consider this same point here. Now f of x plus 5 now is equal to e to the x plus 5. What if x is 0? This will become f of 0 plus 5, which will be e to the 0 plus 5, which is e to the 5, which turns out to be around 148 point something. Now that means instead of cutting this curve here at 1, it will now cut this curve here at around 148. Here, 0, 148.413, etc. And now I just draw my curve. So I go like this, and I go like this, or something like that. Oops, sorry. I'll just alter that a bit. Right, now I'm only doing this because I'm doing this on a computer, right? You shouldn't do this when you're on paper. Right, and that now is my new curve, f of x plus 5, which is equal to e to the x plus 5. You notice my curve, the particular shape of the curve, the blue curve and the green curve should not change. It should not stretch, it should not shrink, it should not anything. All I'm doing is I'm shifting it 5 units to the left. To the end of my first video on the horizontal, on graphical transformations, right? I've covered vertical translation and horizontal translation. Tune into my other videos where I cover stretches. Thanks again for tuning in, guys.